Try that.
Okay. Don't rewrite the drawing because it's the same drawing for several slides in a row. So here's just a little more of a description. Depending on how reactive the zinc is and how reactive the hydrogen is, depending on what combination of chemicals we use for what's oxidizing and what's reducing, the force with which the electrons are pushed through that wire can vary. Now there's a word that we use to describe that. I'm going to try to not say the word until the next slide. It's on the next slide. And you might have a sense of what the word is, but zinc has a certain reactivity. It's got a certain ability to get rid of electrons. So that determines how much it's pushing the electrons through. And then hydrogen has a certain ability to grab electrons. That affects how much the electrons are pushed through. That ability, or that force that the electrons are being pushed through with, is known as potential difference. You might have heard that as a sciencey term, potential difference, in physics. He might not. I don't know if you get to electricity in physics 1. You get physics 1? You don't get to electricity. What a shame. You have physics 1 or 2?
I'm in 2 AP
You're in
now.
A, okay. Yeah. Have you done this though? You've done some potential difference circuits a little bit.
Yeah.
It's fun. I like it.
Oh, that means Warner's gonna win this battery battle.
Yeah, Lauren's got a good shot, I think. It's the physics people that get
Or
up
I could
there.
just ditch
Physics is
that.
okay.
Let me ditch that. I will ditch that.
Oh, are you inviting yourself into Lauren's group? Is that what you're doing?
Just for the
We're full, yeah, sorry.
Like
Okay, Lauren, I'm going to call on you in a second. I want to know what's another word for potential difference. You got it though, right? Don't say it yet. Just say yes, I know what it is.
I think I know what it is.
Who said that, Samir?
Yeah.
What is the word? It's a word that you've heard of before. I don't know if you know really what it means. I don't think you really know what it means until you've had physics.
What does it start with?
I can't tell you that. Should we tell what it starts with? You know what it is, Matt? It starts with V.
V?
Yeah. Potential difference is also known as what? How much force the electrons are pushed through that wire with. Lauren? Voltage. Voltage.
You're drawing that?
No, I'm writing.
I want to show you something that's in the book. It's a table that's there.
Wait, so potential differences.
Yeah, it's the same thing as voltage. Yeah. Okay, so I'm going to take you to...
Are you sure?
This is page 825 in the book. There is, it's a big table. Oh, look at that. Isn't it a beauty? Take a look at the title of it. It says Standard Reduction Potentials at 25 degrees for common half reaction. So a half reaction, that tells you it's redox. These are only reductions. The whole table is all half reactions that are reductions. Now if I can zoom in on it, let's take a look. First of all, I want you to notice what the title heading, or not title, the heading is. The half reaction is down here. And notice for all these half reactions, electrons are in the reactants. That means it's reduction. They're gaining electrons. Over here, V for volts, that's the unit, is volts. Then we have that symbol. Can you see it? It's a scripted E, a real fancy script E. I'll zoom in on a little more so you can see.
Is that a Greek letter?
See it?
Yeah.
No, it just stands for like E, electrochemical potential. E. Okay? So this table gives the things that reduce in order from the best reducers down, and through the whole thing, it kind of ranks the ability of things to reduce. So at the top of this list is fluorine, F2. Fluorine is the best reducer of anything in the world. There's nothing that gains electrons better than fluorine does. Now when you're thinking, oh, I need to make a battery, and I need the highest voltage in the class to get extra credit, I'm going to find myself some fluorine.
Oh, I'm gonna write that down.
Time out. Fluorine is banned. It's a banned substance.
Okay, I
No
want
halogens allowed in the battery lab.
AG.
None. No chlorine, no bromine, no iodine.
How will you check?
Why?
They're dangerous. Toxic.
But
Not
if we
appropriate for a high school class.
Swallow.
Yeah, sometimes in high school, if it's been around long enough, you find
It's
stuff.
okay, I'll take my risk.
But yeah, no, we're not. No halogens at all, and no group ones because we'll talk about the group ones in a second. Let's just think of reduction right now. Now I want to take. Yeah. I think we'd have a hard time finding France. Really expensive.
Why? Why is it?
Okay, so anyway, now take a look. This next slide has the word volt on it. I wanted to try to save the word for this one. Potential difference is also known as electromotive force. That's why I'm describing the electrons as being pushed through this with a certain force. That force is determined by how reactive the zinc is and how reactive the hydrogen is. How good is zinc at giving off electrons? How good is hydrogen at taking the electron? They work as a team in the cell. So yeah, that total voltage is determined by both the zinc and the hydrogen. So it's called potential difference, also known as electromotive force, also known as voltage. Oh, a push on the electron flow, E for electrons.
Yeah.
It means with what force are the electrons being pushed through. Now the more volts that you have, the more work that you can do. The more volts, the more work. You all know what 9-volt batteries are, right?
Yeah.
I have to ask it. In second hour today, I talked about putting your tongue on a 9-volt battery, and not one person, thank you Danny, not one person in the class had ever put their tongue on a 9-volt battery. Is anybody in here? Regan, you have.
Sounds illegal.
Lauren? Matthew?
Was that your childhood?
Everybody's childhood when I was
Is this
growing
why
up.
you ended
You can ask anybody that's like my generation if they put their tongue on a 9-volt. Every single one of them will say yes. So far, not one high school student
Because I think it's
has said yes. What?
Baby.
Jemmy, oh my gosh, thank you, Jemmy. Tell us about putting your tongue on a 9-volt. Yeah, it shocks your tongue.
Why would
You know, yeah.
I want to try that now.
you would wake up every day, get out of bed, put your tongue on.
No, I don't like it, but I've done it. I'll never do it again.
Why
Yeah.
do people
There's a lot of people my age, if they have a 9-volt, they want to know if it's good or not, they stick their tongue on it. I'll just put it into the device and see if the device works, but because I don't like getting shot. But yeah, that's Jimmy, when did you do that? In a class here or at home? How come nobody else does it? I mean,
That's because Jimmy's brother's a millennial.
Jimmy,
Like, they were-
you're actually a student, thank you. The rest of you are like doing math when you're 7 years old or
I
whatever,
never did
but
that.
Jimmy was being a kid. Eric, have you ever put your tongue on a 9-volt?
I was too busy studying.
Man, yeah. You guys, you've been robbed of your childhood.
Oh, yeah.
Tell me, okay, I got another one. How many people have eaten glue?
Oh, I did that. I think I did that.
Matthew, thank you.
You know what?
Samir.
Listen, you're just
Only 2 people in this class have eaten glue?
You're just naming things.
Regan?
You're naming
No?
You're being a really
When you were
good
younger, I'm not talking about now.
No, I ate that like Elmer's glue, that like.
Yeah, the Elmer's glue.
My sister, you know what she used to do? What she still does is they just stab yourself with needles.
With what?
With like needles, like
Yeah, you like under the first couple layers? You've done that too, right?
Yeah, wait. I did pierce myself. That wasn't like my skin.
Jimmy, eating glue. You've never done that?
What happens if you mix the glue and
guys-
the battery?
I feel oddly disappointed. You know what? You're reading our
Maybe.
parents tonight. Talk to them about it.
Yeah.
So why
I'll
did
tell
you
your
let
parents
your
how
child do
displeased I am
something
that.
dangerous and potentially life-threatening? What kind of parent are you?
Right.
Look how tricky this is.
I'm disappointed. Not in you, but in the environment that people are growing up in.
Safe
Yeah.
environment.
It's disappointing.
The
All right.
personal.
So I do want to also mention this. Voltage is related to current. Now, you've all heard of current before. Current is measured in the unit amperes or amps. We all heard of amps. I assume, now that I know that you haven't had a childhood, I don't know what you have learned yet. But yeah, current has to do with how many electrons are flowing through. Voltage is how much they're being pushed through. So, you know, if you have a big draw, like a big device that has a big draw on electricity that needs a lot of work done, then you'd use a high voltage.
Wait, so
It's current. You know, we talk about getting shocked and getting electrocuted. It's the amount of current that is dangerous to you, more so than voltage.
so if you have like a low current but a high voltage will matter?
Right. Have you ever seen a Van de Graaff generator? The big steel ball that you have a belt running through, and you put your hand on, your hair stands up. You've seen these in museums, or some physics classes sometimes use them. I don't know, you don't maybe get to it in Physics 1, but you guys probably did it. Van de Graaff generator you never used?
No, you use it in physics one.
In what?
You do it in physics one.
In what? You did. Who'd you have?
Morrison.
Morrison. Yeah, I believe that. Anybody else have Mr. Morrison?
I wish I had.
Oh my gosh. Van de Graaff generator is so funny. Yeah, you put your hand on it, your hair stands up, it builds up charge in you. And like the electrons build up in you.
Oh, I did that with
And
the
then if you
blue
touch
one.
somebody else, they get shocked. And you can have several people standing in line on a bucket. Like you're insulated, and you can have lots of people build up a huge amount of charge. And then you can actually see the shock when you shock somebody with it. It's hilarious. I had one year, I was teaching like the lower level class that doesn't exist anymore. It's called Matter, Energy, and Space. And so I had a bunch of kids on the buckets that were holding hands and holding the Van de Graaff. Just one person on the end has the Van de Graaff. Everybody else is building up charge by holding their hand. Well, they were all in a line, actually out the door, so that people that walked down the hallway, they would shock. They'd get this huge shock. Ow! So I had one student that was right in the doorway. And he was a kind of a tall kid on a bucket. And I'll never forget this. A spark was going between his head and the metal door frame. Like all those door frames are metal. And so you could see this blue arc. He was like, ah! Oh my gosh. He didn't even think to let the other person's hand go. So he was just like constantly getting this spark. It was so funny. So if you take physics, ask when you're going to have the Van de Graaff generator out. Just ask him to take it out and show it to you. It's really, really fun. If you like getting shocked, you probably know that me, I don't like getting shocked, so I just stand and laugh at the people that like it. What? Oh, that insulates you, because if you're standing on the ground, then the charge just runs into the ground. It does, yeah, you're grounded. When you build up charge, it just goes right through your shoe soles into the ground. And so, yeah, the big plastic bucket insulates you from having the charge run through you into the ground. So yeah, you just build it up in your body, and it's
Can you do
really
that
fun.
kind of figure?
I don't know.
Please let's
Just
do
steal
that.
one of them. They're obviously not using it.
Yeah, we
What do you
should.
mean they're obviously-
Lauren, you've missed out. You're taking AP2 this year,
Yeah.
and you've already been through the electricity?
Yeah, but she said maybe at the end of the year. Like
Okay,
we're short
okay.
on time.
Do not let her miss that, or have you guys miss it. All right, last thing? Last thing. This cell, this system, is known as an electrochemical cell. That's our reading assignment tonight. Remember, you are having the reading quiz tomorrow, even though we're going to be downstairs. I want you to read up on electrochemical cells. We're now going to start getting into the math because the total potential for the cell, the voltage of the cell, is determined by the oxidation potential of the thing that oxidizes plus the reduction potential of the thing that reduces. Add those together, you have the cell potential. This is what you're trying to maximize in the battery lab, the cell potential. You want something that oxidizes really well, and something else that reduces really well, put them together into your cell and try to get that high voltage.
We only have one test left in the building.
Mm-hmm. So that this quarter is only 2 tests.
One test.
And fourth quarter we'll have 1 chapter test and then 1 lab test where it's not written, but that's the stressful part that you were asking me about.
Oh, the lab on the last day?
Yeah. No, not on the last day. That's just going to go in as a lab grade. But there's going to be a big lab project. I'll explain to you. There's going to be 2 test
Yeah,
grades in
kitchen
the last
lab.
quarter.
Is it only 25 points?
Yeah, but the number of points don't matter. It's all based on percents.
So should we just write the
Yeah, I mean, you could write it like this. That's the way I would write it if I'm writing by hand. Or you can do like the book does and, you know, that's something like that. I mean, it's wild. The Zoom dolls went all out on that one. Okay. And by the way, on the AP exam, I believe the E that they use is just a scripted normal capital E, but not scripted, italicized. They just take a normal capital E and italicize it. But the book, yeah, the book, man, they have fun with it. Just one other thing, if I could. I talked about this table that has the reduction potentials on it. There it is. Okay, I want you to notice one thing that's reducing on here. I got to get those numbers. Look at, it's about 1/3 of the way down, hydrogen. 2H plus 2 electrons yields H2. You see it?
Yes.
The hydrogen reduction? Look at its reduction potential. 0.
Not
Everything
really
above hydrogen is better at reducing. Everything below hydrogen is not as good at reducing. So if you have a negative reduction potential, that means that that substance is not interested in gaining electrons. However, the product of reduction, if you turn it around, that could be oxidizing now. So just under hydrogen, I lost, is iron. Now iron is not good at reducing. However, the iron plus 3 ion is not good at reducing. The iron neutral is good at oxidizing because what we'll do is, for anything oxidizing, you'll take the reduction and turn it around, turn the equation around, and then you just change the sign on the reduction potential. So iron with a positive 3 reduces with negative 0.036 potential, but iron will oxidize to iron plus 3 with positive 0.036 potential. So we're going to use this same table for both oxidations and reductions. If you need the oxidation of something, you have to find it as a product and turn the reaction around, turn the half reaction around. Those will be oxidations now, because they're giving off electrons if they're turned around. So I'm going to go down to the bottom of this thing. What element is the best at oxidizing? Lithium is the best at oxidizing. Because when you turn that one around, the oxidation potential of lithium would be positive 3.05. So yeah, the best cell would be lithium reacting with fluorine. Because fluorine's the best reducer, lithium's the best oxidizer.
Using lithium.
However, lithium is a group 1 metal, it's band 2. So no lithium, no sodium, no potassium, no cesium, no rubidium, and definitely no francium.
Okay, so what do we got?
Explode if I touch the water. Yeah. So what can you use? Anything other than group 1 and group 7?
Okay.
You can use magnesium or calcium. Those are good. Look at the oxidation potential of magnesium. It's good.
Barium's good.
I can't remember. In fact, if I remember, I wouldn't tell you. I want you to figure it out on your own. All right? Okay, I'm done for today. See what I mean? I can't hear with background
I
noise.
should be
Yeah, we use
It's
online
been like
video.
over half a year. But are we doing 1 cell or 2 cell?
I will.